Hello everyone, Mr. Linder here. Let's talk about different types of skeletal muscle fibers or different types of skeletal muscle cells. So skeletal muscle fibers have traditionally been classified by their speed of contraction and their fatigue resistance. As we learn more and more about skeletal muscle anatomy and physiology, it's important to note that muscle cells actually have plasticity, and they can shift fiber types depending upon activity and types of exercises performed on those muscle cells. However, at this point in time, there are three accepted types of muscle fibers. There are the slow twitch, also referred to as the slow twitch oxidative or type 1 muscle fibers. And there's two varieties of fast twitch. There are the fast twitch glycolytic, which are also referred to as the type 2B cells. And there's the fast twitch oxidative glycolytic, which are the type 2A cells. Oftentimes, those type 2A cells or fast twitch oxidative glycolytic cells are referred to as intermediate cells. And those intermediate cells have the most plasticity of the cells. And we see those cells transitioning based on training into either slow twitch variety or faster twitch glycolytic variety, depending upon what type of exercises you're performing on your musculature. Fast twitch fibers develop tension faster than the slow twitch fibers. It's estimated that they're about 10 times faster than the slow twitch. Fast twitch fibers are typically used for fine, quick movements, while slow twitch are constantly used for things like maintaining posture, standing, or even walking. When we refer to glycolytic cells or glycolytic fibers, these types of cells will fatigue more rapidly than your oxidative fibers. And that's because of the preferred method of production of ATP. Glycolytic fibers are going to use anaerobic metabolism, and they're going to produce smaller amounts of ATP, thus fatiguing more rapidly. Oxidative fibers are going to use more aerobic metabolism. Thus, they're going to produce more ATP and therefore be more fatigue resistant. And these oxidative fibers are going to have more mitochondria, they're going to have more blood vessels for oxygen transport, and they're going to have higher levels of myoglobin content to be able to hold on to oxygen and maintain that aerobic metabolism. So based on some of those characteristics, you can look at these cells anatomically and actually see some of the differences. So when we look anatomically at the cross-section of slow twitch muscle cells, you'll notice that the slow twitch muscle cells have smaller diameters. Therefore, they're not going to be as strong because they have less myofibrils in them, but they're darker in color because of the myoglobin content. And so they're going to be more fatigue resistant. The fast twitch glycolytic are going to be larger in diameter. They have more myofibril content, so their force of contraction, the tension that's generated in those cells, is going to be greater, but their myoglobin content is lower. Therefore, they look more pale under the microscope, and they use anaerobic metabolism more frequently, so they're going to easily fatigue. So to summarize the different types of muscle fibers, we can use a table like this. So the slow twitch oxidative are the type 1 fibers. The fast twitch oxidative glycolytic, these are the type 2A fibers. And the fast twitch glycolytics are the type 2B cells. So let's take a look at the slow twitch or type 1 cells and look at some of their characteristics. So for slow twitch, Their speed of maximum tension is going to be slow, hence they are the slow twitch cells. Their diameters are going to be small. Their contraction durations are going to be the longest. So they have long contractions and therefore, again, don't produce as much tension, but they're more fatigue resistant. So the fatigue resistance and endurance for slow twitch cells is going to be high. They're mostly used for postural maintenance kinds of activities. In terms of metabolism, they are oxidative, so they use oxygen in aerobic metabolism to make large amounts of ATP. And because they make large amounts of ATP, they can sustain aerobic metabolism longer. So this would be good for long distance runners, cyclists, soccer players, individuals that need long duration of muscle activity without going into heavy anaerobic metabolism and causing those muscle cells to fatigue too rapidly. These types of cells will have high capillary density, so lots of blood vessels coming through these cells. They have high levels of mitochondria to sustain aerobic metabolism, and they have a high myoglobin content to carry high levels of oxygen, and therefore they get the darker red coloration under the microscope. For fast twitch oxidative glycolytic, the type 2A cells, these again are the intermediate kinds of cells, and these are the ones that have more plasticity where they can shift towards slow twitch or switch or shift towards fast twitch in order to change the activity of the cell based on the type of training that you are actually doing and influencing those cells to be one variety or the other. In terms of speed of maximum tension, these are intermediate in their speed of generating tension. They're going to be medium-sized or intermediate in diameter. Their contraction durations are going to be short, which is why they fall into the fast twitch variety. They are not as fatigue resistant as slow twitch, but they are better than the fast twitch. So there is some fatigue resistance, and so they are used in endurance types of activity and training, mostly used for things like standing and walking and things that are going to require some of that aerobic metabolism that they get from being oxidative. So they have oxidative metabolism. They can do aerobic metabolism, but they're also going to be glycolytic as well, meaning that they can use anaerobic metabolism when necessary to sustain some muscle contraction. Their capillary density is less than the slow twitch. It's intermediate in density, also intermediate or moderate in numbers of mitochondria. And their myoglobin content is going to be less than your slow twitch cells, but they still have myoglobin to carry oxygen. And so you are going to see some of that red coloration with the myoglobin and oxygen within these fast twitch oxidative glycolytic cells, these type 2A cells. Lastly, we have the type 2B cells. These are going to be the fastest twitch cells. So they are fastest in terms of speed of maximum tension. They are the largest in diameter of the cells. They have short contraction duration. So again, this is what makes them a fast twitch kind of cell. They easily fatigue because they rely on glycolysis, anaerobic metabolism, and not the oxidative metabolism that you see in aerobic metabolism. So they easily fatigue. These are really the least used as far as the muscle cells. These are going to be for quick movements, not sustained movements. So these are going to be jumping activities, quick sprinting types of activities, where the activity is going to be seconds of time. They use anaerobic metabolism, so hence the glycolytic metabolism. They have low capillary densities, so not a good blood supply. They have very few mitochondria because they're relying predominantly on glycolysis in the sarcoplasm, and they have very few myoglobin molecules to carry oxygen, so they have that pale coloration due to the fact that they have less oxygen content. So these are the three types of cells, the type 1, type 2A, and type 2B. All types can be found within our skeletal muscle organs. We essentially just have a ratio of cells within the organs. So in a particular muscle, say the biceps of the arm, there's going to be slow twitch and fast twitch oxidative glycolytic, as well as fast twitch glycolytic. But the ratio of cells is going to determine whether you're going to get more fatigue resistance or whether you're going to get more power out of a particular muscle. And a lot of that comes down to genetics and the type of training that you do for that musculature. So that's a little bit on types of muscle cells found within our skeletal muscle organs. I hope that helps. Take care.